Hello everyone, welcome to day 4 of Unit 10. Today we're just going to be practicing sine and cosine. What I actually want you to do first is pause the video right here, try the warm-up on your own, identifying all of the key features, so 3A of this unit, before moving forward. Okay, so pause now, and then the video will play so you can check your answers. All right, welcome back. So first thing we want to do here is define what the midline is. The midline, we know, goes through the center of the graph. So let's go ahead and find where the center of the graph is. All right, so we know that that is the line y equals 1. So we always want to write this as a horizontal line equation, so not just 1, but y equals 1. The amplitude is the distance from this midline to the maximum or the minimum value. So how far is it from 1 to 4? Or you could think of it as 1 to -2. And either way, you get the same answer, and the answer is 3. So therefore, the amplitude is 3. The period, you can think of it as a couple of ways. You could think of it as how long it takes to reach all values within the unit circle, how long it is in order to repeat every part of the graph, and you can measure this a couple of ways. You could either look at it as, oh, this is a sine function, so I'm starting here and I'm going to here, and that is a distance of 2 pi. You could always just measure it from peak to peak, and that is from pi over 2 to 5 pi over 2, and that is also 2 pi. So whatever way you want to think of it as, 2 pi is the time it takes to complete one cycle. All right, domain is the same for both sine and cosine. Always, it is all real numbers. So interval notation, -infinity to +infinity. And then the range is from the bottom of the graph to the top of the graph. So from your minimum to your maximum. All right, here, our minimum is -2 and our maximum is 4. So interval notation, brackets, -2 to 4. All right, for the rest of class, all we're going to do is practice graphing sine and cosine and identifying these key features. So a mix of both 1A and 3A. For example, 1, what I want you to do is first fill in the blank. Your blank here is 3. So your vertical stretch is 3. And then I want you to pause the video here and go ahead and walk through the entire example the best of your ability, and then you can come back here if you get stuck. All right, welcome back. So our vertical stretch here of 3 actually tells us our amplitude. Our amplitude is 3. And then our period, for the parent function, it's 2 pi. Since we don't have any horizontal stretches or shrinks, the period does not change, and the period is just simply 2 pi. Now, what I recommend doing is continuing on with our method of using critical values and then applying transformation. So what we've been doing since Unit 1. So what we could do here, for both sine and cosine, we're going to use the same critical values. Just the y values change. All right, so for our x values, that includes 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then for sine, it starts at 0, goes up to +1, back to 0, down to -1, back to 0. And then here, this 3 tells us we're going to multiply all the y values by 3. So what I'm doing first is multiplying all the y. 1 times 3 is 3. 0 times 3 is 0. -1 times 3 is -3. And 0 times 3 again is 0. And then these are the values that I'm going to go ahead and graph. So I'm going to graph all of my x values and then all of these corresponding y values. All right, so I'm going to label it. Yeah, sorry, you can hear Henry in the background. So I'm going to label it 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, and then I know I just want to go to a maximum of 3 and a minimum of negative 3, so I can just do maximum 3, minimum negative 3, and then just plotting these points. 0, 0, pi over 2 up 3, over pi up 0, over 3 pi over 2 down 3, and over 2 pi up 0, and then connecting the points in a nice, smooth sine function. All right, for 1b, I want you to do the exact same thing. I want you to go ahead and fill in the blank. Your blank here is 1/2. Then pause the video and try and complete this problem on your own before checking back if you need to. All right, welcome back. Here, we have a couple things going on. We have this negative out front, which means we have a reflection across the x-axis. And we also have this 1/2, which means we have a horizontal stretch by a factor of 2. All right, so our amplitude, we always can tell just from our vertical stretch. Well, we don't have a vertical stretch, so we know our amplitude is just 1. And then our period here, since it is being horizontally stretched by a factor of 2, what we would want to do is 2 pi times the reciprocal of 1/2 is 2 over 1. So therefore our period is 4 pi. So we know that the length to complete one cycle is 4 pi. All right, what we're going to do now is the same thing we did last time with making a table of critical values. So here I have x, and this time we're doing cosine of x. So the x values are exactly the same as they were before. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now the y values change a little bit because cosine starts at the extremes. So at 0, we're actually at 1. And then we go to 0, and then we go to negative 1, and then back to 0, and then back to 1 at the top, the maximum. Okay, now what we're going to do is apply our transformations. Since we have this negative out front, that means I'm going to multiply all of the y values by negative 1. So let's go ahead and do that. Multiplying all the y values by negative 1, I get negative 1, 0. Negative 1 times negative 1 is positive 1. 0 times negative 1 is 0. And then 1 times negative 1 is negative 1. And then what we want to do with our x values, we have this 1/2. Remember, x's behave not in the way you would expect. So rather than multiplying by 1/2, we're going to multiply all of the x values by 2. So we have 0 times 2 is 0. Pi over 2 times 2 is pi. Pi times 2 is 2 pi. Yep. 3 pi over 2 times 2 is 3 pi. And 2 pi times 2 is 4 pi. All right, and then all we need to do is graph these values. So we have our x values over here, and then our y values in this yellow. So what I'm going to do is label my x-axis with 0, pi, 2 pi, and 3 pi, and 4 pi. Zero, pi, 2 pi, 3 pi, ooh, way zoomed in, and 4 pi. And then my maximum is +1, and my minimum is -1 along my y-axis. Okay, and then from here, what we want to do is just graph these values. So at 0, we're at -1. At pi, we're at 0. 2 pi +1. 3 pi 0. 4 pi -1. So we get this reflection of the cosine graph. And we're done. All right, we made it to the last one. What we're going to do is go ahead and fill in our blank. This blank for example 2 is -3. All right. And then this one is all it's asking you to do is find the domain, the possible inputs, the possible x values, and the range, the possible y values. So domain of all of our sine and cosine functions is all real numbers, so -infinity to +infinity. And please notice that it says summary sheet, domain and range. So I want you to write for domain and range, or for domain, you're going to write all real numbers for sine and cosine. That's not true for all trig functions, but it's true for all sine and cosine functions, which is what we're studying here. Now for the range, you're going to have to do a little bit more work. I want you to think about first the parent function for sine and cosine. For the parent function, it starts at -1 to +1. -1 is the minimum, +1 is the maximum. And then what we're going to do is apply transformations to these. So we can see here we have a vertical stretch by 3 and a reflection. So let's go ahead and apply the transformations. We're going to multiply these by -3, which gives us 3 to -3. Well, that doesn't really make sense for interval notation because it's not in numeric order. So you're just going to rearrange it to be -3 to +3, which is saying that the minimum value is -3 and the maximum value is +3. All right, so to close out today, what I need you to do is find your summary sheet for Unit 10. It should be in your Notability file. And for domain, we're following all real numbers. And then range, I want you to write that you have to first apply all vertical transformations and then write your answer in interval notation. All right, have a good weekend, everybody.